Namaste, I am JVM Dr. Kiran Yadav. Welcome to the digital session of JAYOTI VIDYAPEETH Women's University. And this class is for B.Sc B.Ed and B.Sc PCM students each semester. The topic that will be discussed in today's class is binding energy curve. As we previously studied about binding energy, the binding energy is the energy required by a nuclei to break it into its components. So if I have a nucleus and I want to break the nucleus into its components, which are protons and neutrons, then I will need to give some energy to the nuclei so that it can break. Okay, so binding energy is the energy required to break a nucleus into neutrons and protons. So binding energy curve is a graph that is plotted between binding energy per nucleon and mass number. Okay, so this is a curve between binding energy per nucleon and mass number. So this is the curve. On x-axis there is mass number A, and on y-axis there is binding energy per nucleon. Okay, so what is the importance of this curve? Well, the importance of this curve is if the value of binding energy per nucleon for a nuclei is high, then it means the nucleus is more stable. Okay, and if the value of binding energy per nucleon for a nuclei is less, then it means the nuclei is less stable. So, well, this can be understood in other terms as well. Suppose the binding energy per nucleon for a nuclei is quite high, then in that case the energy required to break the nuclei will be higher. Okay, so more amount of energy will be required to break the nuclei into its components, which are protons and neutrons. So we can say that the nuclei is quite stable because a small amount of energy cannot break the nuclei, so the nuclei is stable. And if the value of binding energy per nucleon is less, and when we give small amount of energy to such nuclei, then the nuclei can easily break into its components. So the nuclei is less stable, for which the value of binding energy per nucleon is less. So this is the binding energy curve. Initially, for nuclei having mass number between 0 to 20, the values of binding energy per nucleon are less, and then for nuclei with mass number 20 to 120, the values of binding energy per nucleon are highest, and it is maximum for 56 Fe. Okay, then after 120, the value of binding energy per nucleon decreases as the mass number is increased. Okay, so in this reason, well, there are some spikes in the curve. Okay, there is a zigzag kind of curve and there are some spikes. Well, I will explain you why it is so. Well, there are some key points of this curve. First point is there are some peaks obtained at certain values in the range when mass number is from 0 to 20. Okay, so if like there is 4 He, there is another peak of 8 beryllium, then 12 carbon, then 16 O, then 20 neon. Okay, so there is one trick in which you can remember these names is, here you can see that the value of this mass number A is 4, then 8, then 12, then 16, then 20, which is the table of 4. 4, 8, 12, 16, 20, all are the multiples of 4. So in this way you can remember these names. Okay, and the nuclei that are on these peaks have higher stabilities as compared to their neighboring nuclei. Okay, so 4 He is more stable as compared to its neighbors. 8 beryllium is more stable as compared to its neighbors. Okay. This rule is also known as 4n rule, where n is 1, 2, 3, 4 and 5. So you get 4, 8, 12, 16 and 20 values. Okay. Then in the reason from A is equals to 20 to A is equals to 120, the value of binding energy per nucleon is nearly equal. Like there is not so much variation in the values, and it is maximum for 56 Fe, which is equal to nearly equal to 8.8 mega electron volt, which is highest. So 56 Fe is the most stable nuclei. Okay. So here the value is not changing much, and it is almost constant, not exactly constant, but it is all approximately or almost constant. So we call this region as saturation region, because the value of B by A is saturating in this region. And after A greater than 120, the value of binding energy per nucleon decreases rapidly. So the nuclei which are in range from 20 to 120 are most stable, and the nuclei which are in range A is less than 20 and A is greater than 120 are least stable. Okay. So this was the binding energy curve. If you have any doubts, please mention in the comment section. Thank you.